Hello and welcome back. Today I have something great. I mean, big. I have two of these meters, and they actually came with other stuff I bought in one package. I was not familiar with the brand. It is from Ellen, which is a German company, Lucas Nulle, and they are mainly in education. So that's why this big meter. And if you think, well, big, I cannot really see now. I'm here as a comparison. I put a few multimeters, and if you think, yeah, I remember from school we had these big Philips multimeters. Well, I have them here. They were not that big. So yeah, we gonna see if they still work. And I see one improvement: the switch here is broken, the on-off switch. I have a similar one, so maybe we can fit those, but I just wonder if they still work. So let's first see what it actually is. And well, this one says it's an RMS meter, Effektivwertmesser. Well, probably it means the same. My German is not that good. But you can see it can do AV or RMS, AC or AC plus DC. I have here the 0, the I and the U, so this is probably to measure the amps. This is to measure the voltage. So it seems that it can almost all, I think it can do watts also, I'm not sure about that. But we can have a closer look at that. And here, this is the wattmeter, electronic wattmeter, Leistungsmesser. And well, you can switch it from 3 volts to up to 1000 volts, and it can even go up to 30 amps, which is really amazing. It is a lot, and you can do power watts or a Q factor. Well, I forgot what that actually is. And this one also 30 amps up to 1 kilovolt. Well, if your meter is this big, you can space the components farther away from each other, which means you probably can do a higher voltage before it starts to jump. Yeah, let's just see, here you can measure indeed the amps and the U's, but not simultaneously, and here you can do simultaneously. There is some table here, I will zoom in on this, and well, I can put these away. As you have seen, they were big, but in the end not that big. Okay, having a closer look. Yeah, it doesn't come with batteries because, well, you can imagine if you operate this in a school, you need to replace your batteries all the time. It makes no sense, and you have a break in your class lessons. Comes with a plug, very convenient, and yeah, I could just see if it even works or not. So let me plug it in. Yes, I see a light. You cannot switch it off anymore, as you can see, but maybe I will replace the switch. You can do AV or RMS, AC and DC, so I will put it on DC. I can put it on 10 volts, and I'm not sure it can provide enough current, but I can try to put it on my electronic load. Sorry, on my voltage reference. And let's see what it does. So we put it on the U and on the 0. And it doesn't do anything, so maybe I need to go one beat low. No, it doesn't do anything. Let's put 10 volts. But maybe it cannot provide the current that is necessary. So let's put it on a proper power supply. Okay, I now try to do the current. I put my electronic load. It says 1 amp. It says 1 amp. It doesn't say anything. So we're just going to open it up. Okay, it's open and it has a lot more electronics than I thought it would have. Look at this. The meter is huge. And well, okay, it works fine. I will just put this on the floor. And I think I saw that one of these lights were on, so I think the power supply works. We can try that later. It is very warm. So I think it has 2 voltages. We can measure that. And we have here the big meter. That is actually quite cool. And these probably are the shunts. Look at this. Yeah, this is the shunt. And I just measure the voltage with these 2 little wires. That is fine. Yeah, that's one way to do that. Okay, well, first we can check if the voltages are there, because there are 2 regulators here. And this is 15 volts. And the other one also. So it seems to be plus and minus 15 volt. So let's see if the voltages are there. Okay, let's see. So it is switched on. I see a light. The electronics seem to work because I have here the minus working. So it seems that it has power. But I don't know if both voltages are there. And the power supply is very straightforward. Just 2 15 volt regulators, 1 plus 1 min. Well, the minus does not work. The minus does work, but the positive 15 volt does not work. So yeah, let's see if I have one in my drawer. Yeah, that's clearly. It maybe got too hot. Oof, it is super bloody hot, so there could also be a short circuit. Let me cut the wire and see if we have 15 volts then. No. Could be a short. Minus 15. Plus 15. So it is a short. Okay, so we need to look in the circuit if something has shorted there. Because clearly it got super hot, and that is a sign something is wrong. Yeah, and now we have the minus 14.6, so almost minus 15, and now we also have the plus 15. So okay, so let's see in this circuit of the plus 15 volts if there is something wrong there. Let's open up some more. Well, the thing I noticed that they have here, I don't know, maybe for the high voltage they try to protect here the input circuit, and they did the same here. But this one is very close to the board, as you can see, and this maybe even shorted something. So I like to bend that back to be sure it doesn't touch anything. And I see a few tons that I will see if the tons capacitor, if they are not shorted. And yeah, that's a start. Okay, I don't know if it was smart. But what I did, I put just 15 volt on the part that is that was almost shorting, and then I saw already that my tracks have burned. And if I check where I will zoom in on the tracks. So if you swear this trace here and this trace here, they are burned, and nothing is burned here. So I would think it's in this direction. And if you look here we have the two tons. So probably these are shorted. So I will take these out. So I will be measuring first. I will be measuring over the tantiles. And DC, of course, it should not have a high resistance. So let's measure. This one is 4 point. Okay, yeah, this one is 0.17 ohms. And that is maybe my yeah. That is just mine. So this one is shorted for sure. And that is also exactly where the track goes. And this one is 400 ohms. Well, I never trust those tantiles if they get old. But here is one. A few megs. This one is also a few megs, so that is good. I have another one here. How much is this one? 10 meg. Dat is ook goed. Here is another one. A few meg. A few 600 ohms. Okay, so this one. Let's do this again. Maybe I replace this one. Okay. So it depends on the election also. Yeah, this one is a clear short. This one I also don't trust. I will also take out. Okay. So first, in the power supply section, we are going to replace the two tantiles here. There are not too many, maybe I just replace them all, but first I just want to see if it works or not. Yeah, it seems that they are 10 microfarad by 35 volts. I have here 10 microfarad by 50 volts, and I use normal electrolytics, because nowadays the electrolytics are a lot smaller than they were then. So that's why they started to use the tons. But these ones, you also have them in blue. I don't trust them when they are old. And we probably can see that it is a short. One was good. Well, this one could have been good if there was one that had a short. Yeah, this one clearly has a short circuit. It is 0.2 ohms, and it is probably my cable. Yes. So that's a short. So we're going to replace with normal, and we see again. Okay, I replaced the little caps, and I repaired the traces with one of the pins of the capacitor I put in here. So the two electrolytics are in. So let's see if it works. First I will do again the test, but I will use my other power supply because this one uses can provide 40 amps. So if you want to be sure you blow your traces, then you use that one. I don't want to do that, so what if I put it here? 15 volts, and then at least this is limited to 1 amp. Okay, that is good, I think. Yes, the circuit works. Okay, perfect. Let's put it back together. Okay, and this I put it back together, but it's not closed, so I put some protection. And yeah, the meter already gives a signal, but you see that with a lot of meters that they are a bit of drifting when there is nothing connected, and that's because of its high resistance. So usually when you short, it should go back, and you see it. Yeah, it does a few millivolts too much, so that's probably just adjusting. So let's see. If we use the voltage reference, we are here on 3 volt setting, so I will start with 2.5 volts. Yes, and it's not that accurate. It should be 2.5, so that should be here, but okay. The next one is, first I go to the 10 volt scale. It's the top one, and now it says it's almost 3. So let's go to 5 volts. 5 volt seems accurate. Go to 7.5, not enough, and we go to 10. So if you can see, first it is too low, and then it's too high, and then it's too low again. Go to the 30 volts, this scale, so now it thinks it's 12 volt. But it mentions nothing on AC. At least it works a little bit. Okay, I created also a little setup. I have my electronic load. Maybe I can adjust. Yeah, I have my electronic load just here, and my power supply 0. Well, this is 0. That is just not good. So maybe we just need to put a screw or adjust something inside. I'm in the 1 amp setting. I put my electronic load to 1 amp, and indeed it says 1 amp, and it says here 1 amp. So let's go to 3 amps, then it should go about here, and it does that. And maybe I can do 2 amps. Amps, 3 amps. Now we are on the 10 amp setting, this one, so but in 3 amp it says okay, it's about 4, so it's really off. 5 amp, 6, 7, 8 amps, 10 amps. Oh, my cables are still good. Let's see if we can go a lot harder. So, and now in the 30 amp, it says here it's already 12, so it's those 2 points off, so maybe I can just turn that back. Maybe it's this, because $15 amp. Okay, I'm going back to 10. Switch to the other scale. Yeah, here it's too low. go to 3 amps. Here it says 3. Here it says almost 3. 1. It says 1. Here it's almost 1. Okay. It does work. So it all seems to work, so I can just continue the cleaning. And the switch that is broken, I have here another one. It does look a bit different, of course, but I also have a rubber cover, and if I put a rubber cover on top like this, it almost looks like exactly what it was. So I'm gonna try to fit this one in, and then the on-off switch works again. And I try to, if I can get the glue off. It is kind of a dirty stuff. Here is a sticker. It will leave residue, and we just need to see if we can clean it. So here we have it, the before and after. The other meter I will do another day. But I think you can see the real difference. The other one is really nice and white. I like how the switch turned out. And yeah, they are not that precise, but they are not precision instruments. You will get a very fair idea what you are doing. And well, that's what they are for. So that's it. One nice meter, one dirty one still, and also I don't even know if it works or not, so I'm gonna do that another time. This one is good enough, so and I like the result. I was thinking of donating it to a local school. So if you have a school or you're educating people with electro or electronics, and you think, well, I like this meter, just get in touch with me, and we will arrange this. So that's it. Thank you for watching, and I hope to see you next time.